11. So let's get started. The first things we're going to talk about are looking at different polynomial functions, how many real zeros they could possibly have, or the maximum number of real zeros, and the maximum number of x-intercepts. Now remember, these two words, the intercepts and the zeros, are actually the same thing, right? So the real zeros and the intercepts are actually going to be the same number. And then the maximum number of turning points. Now, I'm going to write these down, how to figure this out, and then I'm going to explain it with two different graphs. So the maximum number of real zeros and x-intercepts, for that matter, are going to be however much the highest exponent of the function is. So just look for the highest exponent. That's going to be the maximum number of real zeros. And it's also going to be the maximum number of x-intercepts. The maximum number of turning points of any polynomial function is going to be actually whatever the highest exponent is minus 1. So I'll explain all of this in just a minute. So the maximum number of real zeros is going to be whatever the highest exponent is, or in other words, the degree of that polynomial. The degree of the polynomial is whatever its highest exponent is. Same thing for the x-intercept, and the maximum number of turning points is going to be whatever that highest exponent is, but subtract 1 from it. So now we're going to look at two different graphs that we've become familiar with throughout the semester. The x squared graph, which is the U-shaped parabola, and the x cubed graph, which is that kind of just that squiggle shape. So let's relate these three things with those two graphs. So let's look at these two graphs. Remember what your x squared graph looks like. Your x squared graph is that U-shaped parabola, right? So it can either, let's see if it looks like this. That one has one x-intercept, two x-intercepts. So if its highest exponent is a 2, the maximum number of x-intercepts and zeros that it's going to have would be 2. It can have less than that. For instance, if let's say you're an upside down parabola and you're down here, you're not going to have any x-intercepts or zeros. You could have, what if you're a parabola and you touch the x-axis and you go back the other way? You would have one x-intercept. But the maximum number you would be able to have is like this first one that I drew. I can't have more than 2 x-intercepts if I am an x squared graph. If I'm going to have another x-intercept, what would have to occur is one of these sides would have to come back down and cross through the x-axis again. That would give me another x-intercept, but then I'm not the x squared graph anymore, right? I'm not a U-shape. I made another turn and came back down here. So the most it could possibly have would be 2. So the maximum numbers of x-intercepts and zeros that a parabola or x squared graph would be 2. What about the x cubed graph? Okay. There it would have 1. It's only crossing through the x-axis right here. Let's see what it will, how can it have 3? What about an x cubed graph that does this? That's still an x cubed graph, and look how many times I touched the x-axis. I touched it here, here, and here. So it touched it 3 times. So it's got 3 x-intercepts and 3 real zeros. I can't have any more than 3 though, because what would have to occur? If this graph was actually going to cross through that x-axis again, this end of it would have to turn back around and go through it again, which would give it another x-intercept, but then it wouldn't be the x cubed graph anymore. X cubed graphs only have this shape. They do up, down, up. So the maximum number of x-intercepts that could have would be 3. And the maximum number of zeros is the same thing. So let's talk about the turning point maximum. So what did we say about the turning point maximums of polynomial functions? Whatever the highest exponent is, but take 1 minus 1. So let's look at the x squared graph again. How many times does the x squared graph turn? It comes down here, but goes through the vertex and has a turning point right there at the vertex. It stops going down, starts going up. 1 turning point. Same thing here. Doesn't matter which parabola you're looking at, it's only going to change directions or turn 1 time. Same thing here. Only turns 1 time. So the maximum number of turning points that an x squared graph can have is whatever the highest exponent is minus 1. So that's why it can only have 1. How many should this be? If the highest exponent is a 3, the maximum number of turning points would be 2. Well, look at these. Comes up, 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 hits this point, and then does what? Goes down until here, and then goes up. So it turned there and there. So how many times did it have a turning point? In those 2 spots, it turned. So it can only turn 2 times. Whatever that highest exponent is, minus 1 is the number of turning points it can have. So just by those rules, you're going to be able to fly through the first 3 problems now. It's going to give you a polynomial function and then ask you to say, what are the maximum number of zeros, maximum number of x-intercepts, and maximum number of turning points. Can't remember what it does first. Real zeros, max x-intercepts, and maximum turning points. So the first one, number 1, says f of x equals x to the 6th minus x squared plus 7. So all you're looking for is the term, the leading term, which is the term that has the highest exponent, which is this one. That answers all your questions, right? Maximum number of real zeros is whatever the highest exponent is. Same with x-intercepts. Maximum number of turning points is whatever the highest exponent is minus 1. Right, number 2, same thing. So there's my function, f of x equals x to the 7th minus 7x squared plus 8x minus 4. Again, looking for your leading term, which is the term with the highest exponent. Here's my highest exponent. That answers all my questions. Right? Real zeros, 7. X-intercepts, 7. Turning points, 7 minus 1. So 6. And then the last one of these. All right, number 3, negative 9x minus x to the 7th. Now, you're looking for the leading term. Leading term, did I write something wrong? I mean, I'm little, what are you printing off? Are you printing off in the email? It's a PDF. I do not see how it changes. Is yours different too? Yeah. I do not see how it changes. I'm literally printing off a PDF. PDF is like a picture. So the numbers should not change. I have no idea how it's doing that. I can't explain it. I'm going to literally send you a PDF of what I print.
Yeah.
So y'all's are the same, and mine's what's different. I save it as a PDF, I attach it to the email, and print it. I don't understand how it can be changed. I'm going to use I'm going to let you keep it, but I'm going to just use your problems. I'm sorry. So what's your number 3? Okay, so I guess what I sent y'all is different again. So I'm going to use what apparently I've sent y'all. Is that y'all at home too? Is that what y'all's is, number 3? It's driving me crazy. I can't figure it out. Okay, let's go with it. Okay, so looking for your leading term. Your leading term does not mean your front term. It means the term with the highest exponent. That's what we're going with. So this is my leading term's exponent, 6. So once again, the maximum real zeros are 6. The maximum x-intercepts are 6. And the turning points, excuse me, now I'm all thrown off. The maximum turning point is 6 minus 1, which gives me 5. Okay, now the rest of these, 4 through the end, what we're going to do is, because it's going to give us a polynomial function and then ask us to match it to one of the multiple choice graphs, and what we're going to use for the most part is our end behavior rules. So let's go back over the end behavior rules. You're going to want those handy during this section. So if your highest exponent, because that's what you're going with for the end behavior, right, is the term with the highest exponent. If the exponent is even, and it's a positive term, end behavior will be, both ends end up at the upside. If the exponent is even, but the term is negative, your end behavior will both be down at the bottom, going down. If your exponent is odd and the term is positive, this side, the left side of the graph will be down, then it's going to do whatever in the middle, and then the right side will end up going up. And the last possibility would be odd again, but if the term is negative, that would be the left side would start going up, and then it would do whatever in the middle. The right side would end up at the bottom going down. So there's our end behavior rules. Okay, that's going to answer a lot of the questions for us. There will be some problems that we're going to have to look at other things. The other things that we're going to consider, if this doesn't give me my answer, is going to be the Y-intercepts of the graph or the X-intercepts. Depending on how the information is given to you, that's how you're going to tell whether or not you should use the Y-intercept or the X-intercepts. Let me show you the difference before we get to these. If I'm given a polynomial function like this, the first thing I would look for would be the end behavior. Here's my leading term. It's even, and the term is positive, which means the ends should both be like this. If that didn't give me my answer, if the thing is written out like this, I would, remember, if you're going to look for X-intercepts, you'd want to see factors, right? That's what gives you your where it crosses the X. If you see a bunch of things in parentheses, each one of those factors, you would set equal to 0 and solve them for X to get all your X-intercepts. This is not written like that. You could do the factoring or put that, well, you could do the factoring or whatever, if this factors even, I don't think it does. But if your polynomial function is written out instead of in factored form, the easiest thing to do is to find the Y-intercept, because the Y-intercept is going to be, if you replace these X's with zeros, what's going to be left? 8, right? Because here, this means the same thing as Y. So Y equals, if I replace all my X's with zeros, it's essentially just because that'll turn to 0, that'll turn to 0. So all you're going to be left with is Y equals 8. That's going to be the Y-intercept, right? Because how do you find the Y-intercept? You replace the X's with zeros. So if your polynomial function is written out like that, and your end behavior doesn't get you the answer, if there's two graphs that have even positive end behavior, then you can go to the Y-intercept. If your function is written like this, if I'm going to find the Y-intercept, I'm going to have to FOIL this and then multiply that times X minus 1 to get it to be written out like this. However, this is in factored form. I can find the X-intercepts. If you have factors, you just set the factors equal to 0 and solve them for X. That's going to give you everywhere you're going to have an X-intercept. So let's see, I'd have to subtract 3's here to get X equals -3. So there's going to be an X-intercept at -3. Here I'd have to add 1 to get X equals 1. So there's going to be X-intercepts. It's going to touch or cross the X-axis at -3 and +1. So you would look like that. So look at the difference in how you're given the information. If the polynomial function is all the way written out, I would go in behavior first. If that doesn't get me all the way to my answer, I would say, okay, what's the constant? That's going to be your Y-intercept. If my function is written out in its factored form, in those parentheses form, and my end behavior doesn't get it for me, then I would say, okay, I'm going to find the X-intercepts on this one. So just keep that in mind while we're going through these. Let's look at number 4. So a lot of them, you're going to be able to get the answer by just knowing the end behavior, like number 4. So I'm going to keep this up here. Oh, yep. So first things first, let's use our end behavior. What's the highest exponent? Is it even or odd? Even. And is that term positive or negative? Well, it's positive. Which means when you are looking at the graphs, this side, because what's even positive mean? Just come over here and match it. Here's even positive, which means both sides of the graph, at the very end of them, should be up. At the top, going up. That gets you your answer, right? There's only one of those that where the end behavior is both going up, which would be A, right? If that didn't give you, which one of these is this good for finding X-intercepts or Y-intercepts? If you don't see the factors, finding X-intercepts is going to be a little trickier. If it's written out, the number that doesn't have an X on it is your Y-intercept, which means these are both going to be ending up, and that graph is going to cross through the y-axis at -4, which again is A. All right, number 5. Plus 12. Okay. Let's do end behavior first. That's always a good one to start off with. So our end behavior, here's my leading term. Is its exponent positive or negative? It's positive. Oh, not the X. Is its exponent even or odd? It's odd. Is the term positive or negative? Positive. So I'm looking for odd and positive. There's my odd, positive end behavior. So the left side of the graph should be down. It can do whatever in the middle. The right side of the graph should be up. Is this a good graph to find X-intercepts? X-intercepts are going to be tricky there because I don't see any factors. But I do see a constant. If I replace all these X's here with zeros, what am I going to be left with? 12. Which means it's going to cross through the y-axis at +12. Okay, and I'm looking at my, so yours, it doesn't, the hash marks don't even have numbers. So you don't even really know. And you can get it from end behavior on that one, right? There's only one that starts down here and ends up here. But it should also cross the y-axis somewhere in the positive area right there. So your graph should start down. Not worried about X-intercepts. Those are too hard to find on this one. And end up, which would be what? A. All right, number, what are we on? 6?
X to the 4 minus 2x to the 3 plus 10x to the second plus x minus 7.
All right, let's go in behavior. There's my leading term. Its exponent is even, and its term is positive. Even positives mean both ends of the graph should end up at the top like this. Both ups. I think on this one, there should be two of them that do that, right? So I'm going to have to think of something else to distinguish between the two. So is this one a good candidate for x-intercepts? Do you see factors? Or is it a good candidate for y-intercepts, which means you see it all written out, and at the end, there's a term that doesn't have an x on it. That. So this right here is where it's going to cross the y. Here's what's a little tricky on this one. At the bottom of this graph, you will see something like this. So what does this mean? Because I still don't know which graph it is. There's two graphs that have in the end behavior. So what I need to know now I know that it's going to cross through the y at -16. Here's what you got to be careful about. This is telling me those first two numbers are my lowest x in the graph and my highest x in the graph. This right here, my x scale, tells me that my hash marks are going by ones. That's what the x scale means, is what your hash marks count as. So it starts at -5, goes to +5, and your hash marks count as ones. That's what the x scale means. These two numbers are your bottom and top y. But what's your y scale? 10. Oh my gosh, my battery's dead. So my lowest y is -30. My highest y is 70. And my y's go by tens. So 10, 20, 30, 40, 50, 60, 70. It told me my highest y was 70. My lowest one is 30. And they go by 10. So 10, 20, 30. So there's -30. My y-intercept is at -17. So here's -10. There's -20. So it's across the y about right there. That's your distinguishing feature between the two different graphs that have the right end behavior. So when you're looking at the graphs that have the correct end behavior, you're looking at B and C. But C crosses through the x-axis above this. The other one crosses through right above the -20, which would be closer to -17. So that's the distinguishing feature, is that y-intercept. All right, number 7. Okay.
-x to the third minus 3x squared.
All right, let's go in behavior. Here's my leading term. Its exponent is odd, but this time the term is negative. up. Then it does whatever in the middle. At the other end of it, it should be going down. Does that get it for you? It looks like it does on mine. What? So there's only one that has this in behavior. Which one is that? A does. It starts at the top and ends going down at the bottom. Number 8 is going to be very similar. It's going to have different in behavior, but there's only going to be one that has that in behavior. So again, all we're really going to need to know on this one is the in behavior. My highest exponent is even. And that term is positive. Even positive means right side up, left side up. I mean left side up, right side up. Both up. And what is that? B? D as in dog? E as in dog. Both up. All right, number 9 is when we get to the problems that are not written out in their long polynomial form, they're written out in their factored form. So let's look at some of those. What's that one?
X, and then X minus 4 and X plus 5 is infinity, and then X minus 5.
If I says h of x equals that part don't really matter. So let's do in behavior. If I'm doing in behavior, I have to know what my leading term is, or in other words, what's going to be the term with the highest exponent. So if yours is in its factored form, I guess technically it wants you to multiply all that together, which means FOIL, multiply that times that, and then distribute that x. That's going to be take an eternity. All I really need to know is what my highest exponent would be if I did all that. So let's see, if I FOILed this, it would give me x squared. And then if I multiplied it times this, I would have x to the third. And then if I distributed that x, I would have x to the fourth. So in other words, all you really have to do is count your x's. Here's what I'm saying. If I distributed this x, don't do this. I get x squared minus 4x. That would do that. If I multiplied that times x plus 5, here's what's going to give me the highest exponent there, that x squared times x. So then what am I going to have? I'm going to have x to the third with some other stuff. And then I'd have to multiply that times x minus 5, which is going to give me what? X to the fourth. That's all I really care about. Is that's going to be my leading term, is x to the fourth. So x to the fourth is what I get if I would multiply all that together. That's going to be my highest exponent, which means it's going to be even and it'll be positive. There's nothing in that multiplication that's going to turn that x to the fourth negative. All the x's are positive. So I'm going to have x to the fourth, so it's going to be even and positive, which means both up again. I think there may be, is there just one that does that? So there's only one that is both up. But let's say there was 2, just to get some practice now. All your factors are where you would get your x-intercepts. Each factor that has an x is going to give me a 0, or in other words, an x-intercept. So here's a factor. So that's going to give me an x-intercept. And you find them by setting each of the factors equal to 0 and solving them for x. So let's see. That's going to give me an x-intercept. So I'm going to have to solve that one. This will give me an x-intercept. And this will give me an x-intercept. So set them all. So I'm going to have 4 x-intercepts. Every factor that has an x is going to give me an x-intercept. This one's already solved, which means it's going to cross through the x at 0. There's 0 on the x. This one I would have to solve, but how do I solve that? I just need to add the 4 to both sides, right? So what's that one's x-intercept? Positive 4. So it's going to cross the x-axis at positive 4. What about this one? X plus 5 equals 0. So I'd have to subtract 5 to solve it. So here, x equals negative 5. So it's going to cross through the x at negative 5. 1, 2, 3, 4, 5. And the last one, if I added 5 to solve that for x, I get x equals positive 5. So there's another x-intercept. 1, 2, 3, 4, 5. So then you would go through, if the both up and behavior didn't solve it for me, if there was multiple graphs that had both ups, then you would be looking for the graph that crossed at negative 5, 0, positive 4, and positive 5, which again is D as in dog. Okay, let's look at number 10, because I think we will have to go to this method. Okay, what's 10? Minus 1. All right, let's do our end behavior first. In other words, count your x's. If your parentheses has a squared on it, that means that's an x squared in that parentheses. So this is 1. If I FOILed this, because that's what that would mean to do, x minus 1, x minus 1, that would give me 2 more. This would also give me 2. So what's going to be my highest exponent if I actually went through and multiplied all that together? 2, 2, and 1. So I'm going to end up with x to the 5th, and this one does have a negative x, which means it's going to end up negative. So that's going to be my end behavior. Odd for the exponent and negative for the term. So odd, negative is my end behavior. Which means the left side of it should be at the top, up. The right side of it should be at the bottom, down. And if I'm correct, there's 2 of them that have that in there. So B and C both have that. So I am going to go to my x-intercepts now, since this is in factored form. Every factor that has an x gives me an x-intercept. So let's see, this one does. Negative x equals 0. X minus 1. Now remember, This squared doesn't mean it's two different x-intercepts. What does this tell me? Remember multiplicity? That's your multiplicity number. That just tells you whether or not that's an x-intercept that crosses the x-axis or an x-intercept that touches it and goes the other way. What does an even multiplicity tell you? It touches the x-axis and goes the other way. Odd multiplicity means it goes all the way through the x-axis. So let's see, that's going to give me an x-intercept, and so is x plus 4. So let's find those three x-intercepts first. If I solve this for x, I just need to divide both sides by -1, so that'll just give me x equals 0. So there's an x-intercept. This x-intercept, I would need to add the 1 to both sides, so x equals +1. So it's going to have an x-intercept at +1. And this one's going to have an x-intercept when I subtract the 4 from both sides at -4. So let's see what's going on at each one of these x-intercepts. This one at 0 came from this factor. We had an exponent of 1, which gave it an odd multiplicity, which means it's going to cross all the way through at this one. So it's crossing at this one. Both of these, the +1 and the -4, came from these, which had even multiplicity. So there it's touching, going the other way. So touch, go the other way, cross, touch, go the other way. So let's see what that would look like. That one was an even multiplicity, so it just touched it. This one was an odd multiplicity, so it crossed. And then it has to, if I'm going to go have another x-intercept here, I got to come back up, touch it, right? That was a touch. Since it was an even multiplicity, I touched it, and it ended up down. So I think the difference between the two that had the correct end behavior was where their x-intercepts were. One of them has the x-intercepts at +4 and -1. So they're thinking that you're just looking at those numbers and saying, okay, +4, -1, instead of setting them equal to 0, solving them, which changes their signs. So you need to pick the one that has -4, 0, and +1, which would be what? C. All right, now what number are we on?
11.
Number 11, 2 more.
X minus 3 is x squared, and then x plus 1 is x to the 4.
So, add your x's. That's going to give me x squared. That's going to give me x to the 4th. So if I put them all together, I'm going to have x to the 6th. Which is even, exponent, positive term. So again, even positive means both ups. These are going to give me my x-intercepts, because I think there's two graphs that both have ups. My x-intercepts If I set those equal to 0 and solve them for x, I'm going to add 3 to both sides here. So x will equal positive 3 and subtract 1's here. So negative 1. So positive 3 and negative 1 are your x-intercepts. So positive 3 and negative 1, both with in behavior up. Both of the multiplicities at these x-intercepts are touch and go the other way, right? Which means it comes down here, touches it, goes the other way, touches it, goes the other way. Which would be what? Again, I think the difference is going to be one of them will be at negative 3 and positive 1, but the right one will be at positive 3 and negative 1 for the x-intercepts, which would be what? D is in dog. And last one. Oh, I just erased it. Go ahead.
10x to the third minus 8x squared minus 40x plus 32.
Okay, so this one's all the way written out. So I'm not going to try to find x-intercepts on this. I don't see my factors. That'll be too hard. But I can still do in behavior because, let's see, here's my leading term, so it'll be odd and positive. So odd positive means left side down, right side up. I think there's two that are like that. Now, here's the weird thing about this one is look at the numbers on your y-axis. 250. And then there's 1, 2, 3, 4, 5 hash marks that get there. Negative 250 down here. Now, why is that important? That's important because I'm also going to use this to find the Y-intercept, right? It's not a good problem for X-intercepts because I don't see factors. If it's written out, if I replaced all these X's with zeros, this is telling me it should cross through the y-axis at positive 32. So if this is 250, it doesn't tell me what the scale is, but if that's 250 and there's only 5 hash marks to get there, that means each hash mark is a 50, 50, 100, 150, 200, 250. So if it's going to be positive 32 is where it's going to cross the y-axis, it's going to be a little below that first hash mark. The difference between the two that have this in behavior is one of them crosses through the origin, and one of them crosses through a little above the origin. Which one's the one that crosses through a little above? See? So the one that crosses through a little above the origin, which would be at positive 32, would be C. Okay? Okie dokie. That is the end of 8.2, right on time. So we will do 8.3 on Wednesday. I got Davis, McCauley, Devin, and Alton Gerald online. George, Reeves, Washak, and Outlaw in class. All right. See y'all on Wednesday.